Students, this is the help video for the Unit 1 study guide. Only giving you a partial explanation for the starred problems. So if you're going to add and subtract radicals, you always want to collect a like kind. So when you go here, it doesn't look like there's any alike kinds. So you must first simplify. So coming over here, you have a pair of 3's. There's another pair of 3's. 3 is going to come out. That's 3 times 3. It's 9 square root of 6. Watch the sign, bring it down, bring out the 3. 3 times 3, that's 9 square root of 5. No date stays the same. No date stays the same. Except technically there's a 1 there. Then all you do is you collect like kinds. This is just as if I was saying this was 9x minus 9y minus 2w minus 1y. Radicals follow the same rules as variables. Coming over here, multiplying. Outies, innies, simplify. So your outies are going to multiply. There's a theoretical 1 there. Your innies, outies, innies, simplify. So you are distributing this entire thing. So it goes like this. 3 root 3. That outer 3 multiplies with that negative 4. And that inner root 3 multiplies with the other inner root 3. You check the signs. That's positive. That's negative. So your sign is negative. And we go like this. Your outie is 3, and your innie is going to be 3 times 10. From here, you factor. We have a pair of 3's. They're going to come out completely. And nothing stays because nothing's left behind. Here, there's nothing that has a date, so it stays exactly as it is. This is 3 times negative 4 minus 3 root 30. Division, outies, innies, simplify. Your outies, your 2 is going to go into 4. Your innies, all of these are divided by 2. So I end up with 2 root 5 over root 16. I can go top and bottom, root 16, to get rid of it. I end up with 2. I'm going to prime factor 5. Times 2 is 4, times 2 again is 8, times 2 again is 16. That's called prime factoring. Root 16 times root 16 is just 16. Now you take out the dates, which is a pair of 2's and another pair of 2's. So on the outside I have 2 times 2 times 2, square root of 5. And I have a 16. Last but not least, this is going to be 8, 5, 16. Root 5 over 2 is the complete answer there. This page may intimidate you, but be assured it's not that difficult. All you're doing is making an equivalent expression, and you're using a technique I call arrow in, arrow out. Arrow in, arrow out. Let me show you how to do it on this bottom one. First off, you analyze the denominators. Technically, there's a 1 there. So we have a 1, a 4, a 5, and a 20. You're looking for the LCD, the lowest common denominator. And the lowest common denominator of 1, 4, 5, and 20 is going to be 20. Ready? Arrow in, arrow out. Watch what I do. Pencil right there. Arrow in. 1 goes into 20 times. Bring it around. Put little baby 20. 20 times 2, this is going to become 40. 40b. Plus 2. Now we do 4 goes into 20. 5 times. 5 times 3. Watch the sign. That's going to be 15. Minus, minus. 5 goes into 20 4 times. 4 times 12 is 48. And it's B. Equals 20 goes into 20 one time. 1. So 1 times 31 is 31. From here, you collect like terms and solve for B. Taking a look here, says find all possible angles. Keep in mind, that's going to add up to 180. So you use that to solve for x. But you can also go 180 this way, so you can solve for this angle. And you can go 180 this way. So it's going to be 180 minus 67. And it's 113. And then you solve for x and find either the other angles. This particular problem, let me show you what a thing equation looks like. A thing equation. First, you can go all the way around. So we have 3 angles. I'm going to color code them. We have one angle plus another angle plus this angle equals a full circle. This is called a thing equation. Things before algebra. Now using that as a template, use circle, plug, chug. One angle is 24 plus the other angle is going to be x minus 54 plus this angle is going to be 3x plus 2 equals 360. Now you have everything you need to collect like terms. Solve for x. Once you solve for x, find all the angles in the diagram. Taking a look here, use magic fingers. With your fingers on the diagram touching, making little brackets, color coding is very helpful. We're going to get you started on this one down here. First, you identify what you're trying to find, which we're going to try to find UT. Put a little question mark there. Now, you always try to find what's easy to find. So put your fingers, let's start top to bottom. Put your fingers on the 15. 15. Ready? Your 15's from here to here. Fingers. Bring it up. The 15 is also from here to here. Now, move your fingers. Put your fingers on the 27. 27. Fingers 27. Now go back to the 15. Go back down to the 27. 15. 27. 27 goes up here as well. And you see that you can subtract the 15 away from the 27 and you can get this green. So 27 minus 15 is 12. So we get 12 for the green. Now, put your fingers on the 15. 15. Put your finger on the 12. 15, 12, 15, 12. And that should get you your unknown. Use your fingers on the diagram. In the rectangle below, you put your finger right here. In the rectangle below, the width is the length less 10 feet. In other words, the width is 10 feet shorter than the length. The total perimeter is 120 feet. Find the area of the rectangle. Highlight, we have a rectangle. Width is the length less 10 feet. Total perimeter 120. Find the area. Start labeling the diagram. Always label your lengths, which is your longer side, and your width, which is your shorter side. It says the width is the length less 10 feet. In other words, the width is 10 feet shorter than the length. So your equation here is W equals L minus 10. We took care of this, we took care of that. The total perimeter, if you walk it around, your perimeter is 120 feet. We're trying to find the area. So you go through, you'll always start with what you have. You have the perimeter. So perimeter equals length plus width plus length plus width. Now we circle plug chug. Perimeter, and we plug it in. Equals, our length is the same, plus we replace this right there, L minus 10, plus L, plus our width, which is L minus 10 again. Collect like terms. We have 120 equals 4L minus 20. You finish from there, solve for the length, and then solve for the width, and then solve for the area. Remember, your area must have units. Another problem. It says right here in the rectangle, the length is 10 feet longer than twice the width. The perimeter is 50. Find the area. So here we have length, length, width, width. The length is 10 feet longer than, that's a plus concept, twice, that's a times concept, the width. So L equals 10 plus 2W. We are given the perimeter, which is 50 feet. If you walk it around, that's 50 feet. So perimeter equals length plus width plus length plus width. Circle, plug, chug, 50 goes there. Our length is 10 feet longer than twice the width. Bring down the width. 10 plus 2W plus W. Now we collect like terms. That's 2W and W, that's 3W, 5W, 6W. So I have 6W plus 20 equals 50. From here you solve for the width, you solve for the length, and you solve for the area. In the drawings, watch very carefully. You have plane ABCD intersecting a second plane ADST, and you have plane ADST intersecting an ABCD intersecting a third plane CDSR. Now, what is the trick to this whole problem? Watch very carefully. Between the first and second plane, notice they share A and D. That means they are hinged at AD. And then, between the second and third plane, we have CD and DS right here, DS. That means they're hinged at DS. So what's important to understand here, if you have three planes hinged and they share common letters, that we're going into something that looks like a box or a prism, just as an example. So keep in that mind. If it's more than three planes, 3 to 4 planes, you're going, and it's hinged, you have common letters, that means that they share sides, and it makes it 3D. Read the instructions, attempt to draw the rest. For these, you are using your algebraic properties. When I say algebraic properties, that means you go to your reference booklet right here, and you're looking at these 2 pages. The algebra, nope, not the algebra review, excuse me. You're looking at these 2 pages, the algebraic properties page. These are your algebraic properties that you use for this problem. Taking a look here, if I want to solve for my x, step 1, watch. So I'm going to write this out. This is 4x times x equals 2 times 72. X times x becomes x squared. And 2 times this is 144. And divide both sides by 4. I end up with x squared equals 4 goes in there 3 times. 4 goes into there. It's going to be square root of 66. Opposite of squaring is square rooting. And you end up with x equals 6. And you think you're done, but now you have to do the algebraic properties. This first step is cross multiplication property. All right, the next step, I multiplied on one side. That's called multiplication of real numbers. Technically, it's multiplication division real numbers, but we're just going to put multiplication of real numbers. From here to here was multiplication division property, because you divided both sides. You went across the equal sign. Here, this was called the square root property, because you square rooted. The opposite of squaring is square rooting. Problem like this, you want to read out loud first. It says, Stacy is creating a border for her rectangular herb garden with bricks. Each brick is 6 inches in length. The length of the garden is 4 times as long as the width. Area of the garden is 400 square feet. What is the perimeter of the garden? Each brick costs 75 cents each. Tax is 9.5%. What would be the total cost for the border, both the bricks and the tax? Let's get our information on the diagram. Bricks are 6 inches in length. The garden length is 4 times as long as the width. The area is 400 square feet. We want the perimeter of the garden. Bricks cost 75 cents each. Tax is 9.5%. We want the total cost. So, number 1, we ultimately want the perimeter. Because the border is the perimeter. So the border is the perimeter. That's what we ultimately want. We are given the area. The length is 4 times the width. Length is 4 times the width. Length is 4 times the width. Took care of this, took care of that. Area is 400. We want to find the perimeter, and then each perimeter we're going to put these little tiny bricks around to make a border. What do we know about the bricks? We know the bricks are 6 inches, which means in a single foot, 6 inches, 6 inches, a single foot, which is 12 inches. For every 1 foot, you need 2 bricks. If you go like this, about a foot apart, each brick is 6 inches, 6 inches, 6 inches. That's 2 bricks per foot. Always start with what you have, not with what you need. You have the area. Area is length times width. We circle, plug, chug. Area, circle, plug it in. 400 equals, our length is 4W, and then this is W. Here's the trick to the entire problem. W times W is W squared. Now, you solve for W. You solve for the length. You solve for the perimeter. And then realize you need 2 bricks for every foot. So you're purchasing 2 bricks for every foot. Calculate the subtotal using 75 cents a brick and then 9.5% tax. How do you do tax? Tax, you get a subtotal. Then you're going to times it by 0.095%, which, 0.095, which is 9.5%. That will get you your tax. Whatever your tax money is, you add it back onto the original subtotal to get your total cost. Mr. and Mrs. Singh has an herb garden on the side of the house. It's a rectangle. The length is 5 times longer than the width. So the length is 5 times longer than the width. The length is 5 times longer than the width. The area of the rectangle is 125 feet. Find the length and the width. We want to put a border. The fencing is 18 inches. Uh-oh, watch out. That's inches, that's feet. So you need to figure out how many inches 18 is in a foot. So 12 inches make 1 foot. 6 inches make a foot and a half. So your fencing is 1.5 feet. Keep that in mind. You start with what you have, which is the area, equals length times width. 125 equals 5W times W. From here, W times W is W squared. 125 equals 5W squared. You're going to solve for the width, solve for the length, solve for the perimeter, and then do the fencing and the total cost. Good luck.